Knowing how to use your chemistry reference tables can be a big help on the New York State Chemistry Regents exam. Today we'll take a look at Table I, Heats of Reaction, and learn how to use this table. Notice that the title says Heats of Reaction at 101.3 kilopascals and 298 K. Don't let that trip you up. Those are just standard conditions of pressure and temperature, which you can find on Table A. On the left-hand side of the table is a list of chemical reactions, and on the right-hand side we see delta H. Now what's delta H? Delta H is simply called the heat of reaction. It's the energy, usually in the form of heat, that is released or absorbed by a reaction as it progresses. Any reaction, whether it's chemical or physical, involves either the absorption or the release of energy. A reaction that absorbs energy is called an endothermic reaction. We can remember that because heat enters the system. It's endothermic. An exothermic reaction is one in which heat leaves or exits the system. So exothermic, the energy is released. You'll notice at the bottom of this reference table, there's a note that tells you that. So if you forget it, just come back to Table I and take a look. Right there at the bottom of the table, a minus sign indicates an exothermic reaction. So negative delta H means exothermic. If we look at the reactions, they're sort of grouped by category. Look at the first set of reactions. They all start with a carbon-based compound plus oxygen, and the products are carbon dioxide and water. You should recognize these as combustion reactions. The center section of the table, indicated with a blue bracket, are all synthesis reactions. Notice that you have two reactants coming together to form one product. If you reversed these or read them backwards, they would be decomposition reactions. Finally, at the bottom of the table, we have a series of equations that represent solubility. They represent an ionic substance being dissolved in water. These are indicated with a black bracket. Notice that they show an ionic compound being broken up into its ions. The AQ in parentheses after each of the ions indicates dissolved in water, or aqueous. Now let's take a look at some questions that can be answered using Table I. This question wants to know which equation represents an exothermic reaction at 298 K. Remember, 298 K is simply standard temperature. An exothermic reaction means heat is released. Remember, that means negative delta H. We can find that hint on the bottom of Table I. What we need to do is go use Table I, look up these equations, and find the one that has a negative delta H. I've put a star next to the four equations that are listed as choices in this question. Remember, we're looking for an exothermic reaction, so we need a negative delta H. Look at those four equations. Can you spot the one with a negative delta H? There it is. Carbon plus oxygen yields carbon dioxide with a delta H value of negative 393.5. Therefore, the correct answer is number 2. Let's try another one and see if you can answer it. Which balanced equation represents an endothermic reaction? Go to Table I and see if you can find the answer to this question. Pause the recording here while you find the answer. Then click Start again and see if you got the right answer. Did you get number 4? Number 4 is correct. you were looking for a positive delta H because it's an endothermic reaction. The other three all had negative delta H's and therefore were exothermic reactions. Remember, your reference tables are here to help. Be sure to make good use of them.